Assalamu alaikum. We are going to present our project database implementation of a bank management system. This project has been prepared and submitted by our group members MD Shamsuddoha ID 05, Khadija Akhtar ID 18, Saifa Shikdar Shauli ID 13. We will explain the system we designed and how the overall bank management system works. In this bank management system, a customer has a unique ID, name, address, email, and contact numbers and is linked to one branch. Each branch has its own ID, name, city, and manager, and it manages customers and their accounts. An account stores details like account number, type, and balance and is connected to a specific customer. All financial activities are stored as transactions such as deposits, withdrawals, and transfers, including their ID, amount, type, and the branch where they occur. Overall, the system connects customers, branches, accounts, and transactions to ensure smooth and secure banking operations. In this bank management system, there is 4 entities: customer, branch, account, and transaction. Customer entity has attributes like customer ID, customer name, customer address, email, contact number. Branch has branch ID, branch name, city, manager ID, manager name. Account has account number, account type, balance. Transaction has transaction ID, transaction type, and amount. Here in relationships and cardinalities, there are one-to-many relationships in this bank management system. A customer owns multiple accounts, but each account belongs to one customer. A branch serves many customers, but each customer is linked to only one branch. An account records many transactions, but each transaction is linked to one account. A branch has many transactions, but each transaction is recorded at one branch. This relationship shows how the entities are connected in the system. In the ER diagram, the customer, branch, account, and transaction are the main entities. Each entity contains its attributes in ovals. Diamond-shaped block represent relationships like owns, serves, records, and has. The numbers 1 and m represent cardinalities such as one-to-many relationships. The ER diagram visually shows how all parts of the system are connected. This relational schema shows how the ER diagram is converted into database tables. Customer table stores all customer details. Here customer ID is the primary key and branch ID is the foreign key, which links the customer to the branch they belong to. Customer contact table. In the customer contact table, customer ID is the foreign key, which links the contact number to the customer. Branch table has branch ID as the primary key, and in the account table, account nong is the primary key, and customer ID is the foreign key that links accounts to the customer who owns it. In the transaction table, transaction ID is the primary key, and transaction number, branch ID are foreign keys. These tables and foreign keys help the database management system maintain proper relationships between customers, branches, accounts, and transactions ensuring organized and consistent data.
Assalamu alaikum. Our teammate Saifa Shikdar has discussed the ER diagram and the ER diagram to relational schema of our bank management system. Now I am going to explain the normalization part of our bank management system. To normalize easily, we suppose customer equal to R1, customer contact equal to R2, branch equal to R3, account equal to R4, transaction equal to R5, and we let the attributes equal to A to P, like customer ID equal to A, customer name equal to B, customer address equal to C, etc. etc. So the relations become R1 A B C D E, R2 AF, R3 EG HIJ, R4 AKLM, R5 EKNOP. Now we find out the functional dependencies of each relation. For R1, A determine BCDE and D determine ABCE. Here A is customer ID and D is email. A and D uniquely identify and find out the attributes of find out other attributes. And for R2, there is no functional dependency. For R3, E determine GHIJ, G determine EHIJ, and I determine J. For R4, K determine ALM. For R5, N determine EKOP. Now we decompose the relation to highest order normal form. For R1, it is in first normal form. Now we find out the candidate keys of this relation. Here A and D are candidate keys. Now there is no partial dependency, no transitive dependency, and left hand side of the functional dependencies are super key. So it is in second normal form, it is in third normal form, and it is in BCNF also. For R2, there is no functional dependency, so it is in BCNF. For R3, it is in first normal form and the candidate keys are E and G. So there is no partial dependency, so it is in second normal form. But here I determine J, which means non-prime attribute I determine non-prime attribute J. So transitive dependency exists. Now we decompose the relation to R31 and R32 subrelations. Here R31 contains I and J attribute and R32 contains EGHI attribute. Now we find out the functional dependencies of R31 and R32. Functional dependency of R31 is I determine J. Functional dependency of R32 ER. E determine GHI and G determine EHI. For R31, no partial dependency, no transitive dependency, and left hand side of the functional dependency is super key. So R31 is in BCNF. Same as for R32, there is no partial dependency, no transitive dependency, and left hand side of the functional dependencies are super key. So R32 is in BCNF also. Now we check if the decomposition is dependency preserving decomposition and lossless joint decomposition or not. Now we union the functional dependencies of R31 and R32 and we get functional dependency of R3. So the decomposition is dependency preserving decomposition. Now attributes of R31 union attributes of R32 equal to attributes of R3, and if we intersect them we get I, and attributes of R31 intersect attributes of R32 determine attributes of R31, which means I determine J. So the decomposition is lossless joint decomposition also. And for R4, there is no partial dependency, there is no transitive dependency, and the left hand side of the functional dependency is super key, so it is in BCNF also. For R5, there is no partial dependency, no transitive dependency, and the left hand side of the functional dependency is super key, so it is in BCNF also. So all the relations are in BCNF form now. So after the normalization, total tables are customer, which contains customer ID, customer name, customer address, email, branch ID. Customer contact relation contains customer ID, contact number. Branch relation contains branch ID, branch name, city, manager ID. Relation contains manager ID and manager name. Account relation contain account number, balance, account type, customer ID. Transaction relation contain transaction ID, amount, transaction type, account number, branch ID.
Assalamu alaikum, I'm Khadija Akhtar. Now I will show the MySQL database implementation for our bank management system project. Here is the query for creating our database. At first we will create our database named my bank management system, and then we will switch into this database, and then we will create the tables for our database. At first, we will create manager table. These are the attributes of this table where manager ID is a primary key. And then we will create branch table. These are the attributes of this table where branch ID is a primary key and manager ID is a foreign key reference from manager table. After that, we will create customer table. These are the attributes of this table, and where customer ID is a primary key and branch ID is the foreign key reference from branch table. After that, we will create customer contact table, which contains contacts number of our customers. Here customer ID is a foreign key reference from customer table. After that, we will create a table named account. These are the attributes of this table where account number is a primary key and customer ID is a foreign key reference from customer table. And at last, we will create transaction table. These are the attributes for this table where transaction ID is a primary key and account number and branch ID is the foreign keys reference from account table and branch table. After this, we will click the go button to execute this query. We can see our database has created. This is our database, and these are the tables we have created. And this is a schema of our database. Now we will insert data into our tables. This is the query for inserting values into our tables. Now we will click the go button again. We can see the values are successfully added. This is our tables. We can see that the values are successfully added into the tables. This is another query to show customer names with their account number, balance, and their type of account. So at first we are selecting account number from account table, customer name, account balance, and account type. And then we are joining account table with customer table on the condition of customer ID of account table is equal to customer ID of customer table. Then we will click the go button. So we can see that all of the customers' name has appeared with their account number and balance and the type of their accounts. This is another query which will show the customer names who have balance above average. So we are selecting customer name with account number and balance and joining account table with customer table on this condition, and where balance is greater than average balance. So we will click the go button. Now we can see that these three of customers have balance above average. This is another query to show each of the branches with their total customers and total balance. At first we are selecting branch name, branch city, and then count by customer ID, and then sum the total balance, and then join the branch table with customer table on this condition, and then join account table with this condition, and then group the data by branch ID, branch name, and branch city, and then order the total balance into descending order, and then click the go button. We can see the branches with their total customers and total balance. So this is the database of our bank management system. Thank you.